let's take a look at those two functions that I skipped over. The reason I skipped over them was because we were mostly looking at how to kind of just get the hardware initialized, and the swap chain, which are all kind of very flat things. They're not really 3D. But now we'll start kind of segueing into the 3D stuff by just looking at the tail end of the setup, which does start to kind of move into kind of 3D graphics areas. So the window independent setup, this is the equivalent function on the scene object. We already covered it on the actual device object. So first thing we do is just grab a couple of raw pointers that we're going to need. I've just got those exposed through kind of get accessors on the device, on my device class. This first bit of code sets up the rasterizer state. The way the code is at the moment here is it just sets the settings that are already there. It just sets the default settings, so it doesn't have any effect as written. But for example, the fact that it's here means I can easily just change that to wireframe and just build and run, and then I'll be getting wireframe instead of solid polygons rendered. So that's pretty nice to have, but of course it's not doing anything the way it is at the moment. This next bit sets up the alpha blending state. These are just pretty standard, very standard settings the way it is at the moment. I've got this commented out because I sometimes just uncomment that and see what it looks like with coverage, which is kind of like stippled or dithered, you know, like sometimes very low resolution images. If actually not low resolution but low color depth images, they can get some of the colors that are not in the palette by dithering, you know, by actually putting dots of different colors next to one another, so they kind of seem to blend together. This does a similar kind of thing with alpha. So it looks kind of grainy, but the benefit is that you don't have to render from back to front in Z order. So this just sets up that description and then just creates a blend state from that description, and then sets that on the output merger, which is the pipeline stage that does the actual alpha compositing. And then this bit here, all I'm doing is just getting a pointer to a constant buffer off of the device. We're going to use that for our world view projection matrix. But the main thing the main thing we're doing here is just telling it what size it should be. So I'll be able to use this buffer later on to actually update the WVP, the world view projection matrix that I'll be using. Let's have a quick word about that. So it's got essentially three pieces. Each mesh, as I render each mesh sets its own world matrix, world transform, essentially, so that it transforms from the mesh's own local coordinate system into the world coordinate system, and that kind of unifies all the different meshes so that they're all in the same world. And then the view is set every time when the camera moves. The view piece of this changes. The view transformation changes, and then the projection is essentially what we'll look at in a moment. But that's basically the perspective projection. So that's what those pieces are there for. But all I'm doing here is just making sure the thing's the right size and making sure that the device is aware of it for later. Well, actually, not the device is aware of it, because I'll be attaching it into the vertex shader. So all I'm doing is just getting it off of the device so I can use it later. These bits are D2D, not D3D, so maybe we'll come back to those some other time. This is just what I use to render some like frame rate and other diagnostic text, and this is something I use D2D just to draw those like the virtual thumbsticks on the screen. So now let's move on to this second. This is the last one I'll talk about in this video. But the window dependent setup for the scene. We asked the device for the output size, which is essentially the window size in this case, in raw pixels or physical pixels, and then I just work out the aspect ratio and use that to figure out the field of view, and then we set that into the perspective matrix. So I actually use this library function or helper function to make a perspective matrix, perspective projection matrix, which is a transform off of the field of view, the aspect ratio, and then the near and far planes, which these are just class members that I've set to reasonable values. I get hold of the orientation transform, in case you turn your tablet sideways on or your phone side on or whatever it is, and then multiply. Oh yeah, get the orient. Oh yeah, that is the orientation matrix. And then I multiply the perspective matrix, which we just made, with the orientation matrix, and send that into this. Oh, that, yeah, and then that goes into that. This guy here goes into the projection piece. So but that still hasn't been attached to the vertex shader, so we'll talk about that later. And then this is just the that D3D thing, the thumbsticks renderer gets set up. We'll come back to that later. So now we've essentially set up the hardware and the buffers, the swap chain, the render target. We've set up rasterizer state, alpha blending, the projection, all the kind of transformation constants are all ready, although not all filled in. Only the perspective is filled in. So we have to talk about meshes next, and then how do you transform a mesh, and then the camera. How do you place a camera and do the view transform, and then eventually we'll talk about vertex shaders and pixel shaders. So all that's to come in future playlists. I think that's it for this playlist.